For D, we're going to factor 10x squared plus 19x minus 15. So the first thing we always do is we check for a greatest common factor. So with 10, 19, and 15, there is no greatest common factor. So then we need to factor this with a leading coefficient of 10. Okay, so this makes it quite a bit more difficult, but to make things easier, we're going to use that diagonal product property. So we know that the diagonal product in this grid multiplication of negative 150 x squared, we know that the diagonal product in both directions is going to be equivalent to each other. And we know that the diagonal along this diagonal here, we know that diagonal must add up to positive 19. So we need to multiply to negative 150 and add to positive 19. We know we have a negative and a positive. So that means that we need to look at the factors of 150. Well, we know that 10 times 15 would work. Yeah, but that doesn't work. 25 times 6. Well, 25 times 6 would give us 150. And if we have negative 6, positive 25, that's going to add up to positive 19. So this is what we're looking for. We're looking for 25x here and negative 6x here. So we know that the cross diagonals are both equivalent to each other. We know that the sum of 25 and negative 6 adds up to the sum of positive 19x. So that all matches. So then we can just factor this along the axis. So the horizontal common factor here is going to be 5x. Horizontally along the bottom, we have a common minus 3. So we know one factor is going to be 5x minus 3. And then along the vertical here, along here, we know that the common factor is going to be 2x. 2x times 5x is going to give us the 10x squared. And we know that the common factor vertically this way, we have a common factor of 5. So we know that's going to be 2x plus 5. Okay, so there's our factored form. Okay, multiply, if we expand this all out, we get 10x squared. The last number is multiplied to negative 15, and the middle terms add up to positive 19. So that works out perfectly for what we want. So there's our factored form.